Well, I'm Yuyue, and I'm come here to present my work. Let me do it for you towards large language model empowered recommendation while to learning. And this is a joint work with University of Science and Technology of China and the University of Amsterdam and the University of Technology Sydney. Okay, first of all, let me introduce a brief background of our work. For the recommender system, the task is to recommend the items to users based on the historical interactions. There are three types of recommender systems. The first one is the collaborative filtering, which uses user item interaction data. It barely uses the interaction data. And the second one, different with the collaborative filtering, it only relies on the item features. And the third one, it combines both methods, which called the hybrid methods. And our work can be classified into the third one, the hybrid methods. And for the motivation, there are two limitations in existing recommender systems. First one is it are often trained on the datasets which contain limited content data. For example, in movie length, there are only the length of movies or the release years and the genres, which is hard to satisfy the personalized the information and the needs, and not enough to capture the spatial contextual information. And the second limitation is to capturing the user's fine-grained preferences is critical and yet remains challenging. The contribution is we propose a framework called T2.5. Well, which combines the large language models and the tool learning to enhance the recommendation. For the personalized set information needs, we use the large language model to encode the extensive pre-trained word knowledge to addressing the limitation, the first limitation. And for the second limitation, our T2.5 interacting with the external tools in a multi-turn manner, which allows to capture the fine-grained preferences. And the extensive experiment demonstrates the effectiveness of T2.5. In this page, I will give an example of how the T2.5 works. Let's look at the figure. When a user comes, the task of our recommender system is to help the user to find the movies he wants to watch next. Initially, the large language model I will leave it. Let's look at the first turn. Initially, the large language model, it focuses on the movies genres, and it was selecting the 5 movies returned. And in the second turn, it found the returned movies is not, it doesn't satisfy the release year of between the returned movies and the user's profiles. So it targets to the movies by the release year and adding 3 more candidate items. And in the third turn, it focuses on the actors because it thinks the currently candidate items still don't have the specific attributes satisfied. So it ranks all the items based on the attribute of actors. And this step can be multi-turn level, and in the last turn it finished. It found the item list meets the needs, and it finished in the recommendation process. And in each turn, there are 2 important complements, which is the sort and action. In the sort, it can indicate the nonsense of the context, and the user's preferences in the attribute level. And in the action part, it can explore the items by using the attribute-oriented tools to make the candidate items better. Okay, now we know how the tool rack works. Then I will introduce the methodology of how every part works. In the first part, we know we use the user profile to initialize the user decision simulation, and the simulation part will output the source and actions with the attribute and return the quantity of candidate items. And then it will call the external attribute-oriented tools, and the tools will return the items to the memory strategy. The memory strategy will verify the items, whether the items is indeed in the data set, and it will record all the context of the multi-level, and then it will feed the records to the user decision simulation, which is the large language model. And the step 2, step 3, and step 4, it can be several multi-turns, and finally, when the large language model is satisfied, it will return the items to the users. And here is the first important part of the user decision simulation. You can see in the pseudocode, the large language model is acting as a surrogate user, and it will generate the source and actions based on the in-context learning, and the demonstrations which is prepared to tell the large language model how to do such recommendation task. And it will execute the actions and call the attribute-oriented tools while the tool learning manner. And for the tools, we prepared two types of tools. The first type is the attribute-oriented rank tools, and the second type is the attribute-oriented retrieval tools. For the first type of tools, we directly use the large language model to order the candidate item's ranks according to the attribute, because the large language model contains very extensive open world knowledge, and we want to use it to refine the item list. And for the attribute-oriented retrieval tools, we use the traditional recommender systems to retrieve items according to the attribute. And in the how to prepare the retrieval tools, we have two different parts. The first part is we use the sequential model to directly encode the behavior sequence. For example, we use the SASRAC to directly encode the user preference. And then it is fixed and pre-trained and fixed. And then when for each attribute, we will only train the attribute-specific encoder, and then we combine the two parts together to form the user's representation. And when we do the retrieval, it can retrieve based on the attribute and retrieve all the items corresponding to the attribute. And as for the question when to call the tools and to choose what kind of tools, it is decided by the sort, which is the output of the large language model. And when the sort contains the unseen attributes, we will directly call the rank tools. Because for the unseen attributes, since we cannot get such information during the training phase, so we use the large language models open world knowledge to help us do that. And the third important component is the memory knowledge component. And it will update and store the context in each term manner. And it will verify the existence of the generated items, whether it exists in the recommendation data set, and it can address the hallucination problem in recommendation task. And finally, the output will complete the recommendation and return the candidate items to the users. Well, next I will give for the experiment part. We experiment the TORAC on 3 different data sets, and for the evaluation, we randomly sample 200 users and the historical behaviors from the test set. Well, due to the budget concern. Well, the first is the research question is how does TORAC compared to the conventional recommended system and the large language model-based recommended system? You can see in this table the first two recommended system is the conventional recommended system, and the next 5 baseline is the large language model-based recommended system. And we can see the TORAC outperforms others in movie and Amazon Book, and showing its ability to align users' interests. However, in our experiment, we find that the TORAC exceeds worse performance on Yelp 2018, potentially because it aims to recommend, in this data set, it requires to recommend the local restaurant and the bars. So it's hard for the large language model to know such knowledge. So it potentially due to that problem. So our TORAC expect worse performance. And for the research question 2 is how do different components influence the TORAC? And we did an application study here without the tool learning components, and we remove the attribute-oriented retrieval tools. And the third is we don't do the multi-term manner and only ask the language model play once, and then we gather the returned items and the final recommendation list. And we can see in this figure, each part is necessary in TORAC because if we remove each part, and the performance goes downhill. And for the third research question is how do the number of termination round influence TORAC? The number means because we conduct the recommendation in a multi-term manner, the termination round, it means and for the hit round, it indicates the statistics of the termination round for all the users. And we can see the most process conclude in 3 or 4 rounds. And for the hit round, it means where the recommendation list accurately contains the user's target item. And we can say when the process concludes in the 3 or 4 rounds, it gets the more user's target items contained in the returned item list. So we said it indicates the model can potentially understand user's preferences after a few interactions. Okay, and for the conclusion, we propose a framework that combines the large language models and the tool learning to enhance the recommendation. And instead of asking large language model to do the recommendation task, which is hard, and obviously, and we only use the large language model to determine the attribute level nonsense by the context and the user preference. And we don't require the extensive fine-tuning of the large language model, and it's more reliable because we use the memory strategy to address the hallucination problems. And the experiment is demonstrated the effectiveness of TORAC. Yeah, thank you.
Thank you, Zhao.
Thank you.